This first example, you're going to tell whether the ordered pair is a solution to the given system of equations. So we're going to start with this top one. This is 2 problems if you want to like draw a line or something, just so you tell them apart. I'm going to do that for like my sanity. You're checking to see if 6, -1 is a solution to the system that's right below it. So 2x plus 5y equals 7. We want to know if 6, -1 works for that. So we're going to take each equation and write it down. 2x plus 5y equals 7. You are going to take your point and plug it in to see if it makes the equation true. Remember, points are x, y. So, Evan, what should I put instead of x? Yeah.
Sorry.
Yeah. We'll put it next to the 2, yeah. 6 goes here because 6 is equal to x. And Mason, what should I put instead of y?
-1.
Yep. So then we're just trying to see if this will be equal to 7. If it is, that's great. So we'll multiply. 2 times 6 is 12. 5 times -1 and -5. So 12 plus -5, what do we get? 7, hot dog. Okay, so did that one work?
Yeah.
Wow. Okay, so I'm going to put a check mark. That one was a success. But here's the thing, guys. You're not done because it's a system. It has 2 equations. So now you got to take the same point and plug it into the second equation. So let's write down the second one, which is -x plus 2y equals -8. Okay. Eli, what do I put instead of x?
6.
Yep. So it's going to be -6. And Jaden, what should I put instead of y?
A -1.
So that goes in the y spot. Ooh, okay. Do your multiplication, and you've got -6 plus -2. Okay, -6 plus -2, what do we get? -8. Huzzah. Okay, does that work? Yes. Okay, so it worked for both equations. So do you guys think, is this a solution to the system?
Yes.
It is. Yes. Because it makes both equations true. Neat. So you're going to take the point and plug it into both equations. Once you've done that and check to see if it makes the equation true for both, you can make a decision. Okay, we're doing that same thing, but now with the point -4, 3 in the system that's below it. So take x plus y equals -1. Drew, what should I put instead of x?
-4.
Uh-huh. And Evan, what about instead of y? Yeah. If I add those up, what do I get? You do get -1. So did this one work? Hooray, hurrah. But this is a system, so check it. Check the other one. X minus 2y equals 7. I'm going to put -4 where x is. Caleb, what should I put instead of y? Yep. 3. Okey-doke. So 2 times 3 is 6. So we're doing -4 minus 6. What do we get? -4 minus 6. Negative 10. Guys, is negative 10 equal to 7? Heck no. So do you think that this is a solution, negative 4, 3, to the system? No. Because while it worked for the first one, it did not work for the second. So you have to make sure you check both. This one's a little bit different than the ones you saw yesterday because do y'all see this curve? Yeah. Okay, this is called a parabola.
What?
Parabola. But I'm still just asking the same thing. When I ask for a solution to the system, when it's graphed, all I'm asking for is where do they intersect? How many times did these things intersect? Twice. If you see here and here. So there's 2 points. What is the first one? Negative 1, 1. And the other is 2, 2, 4. So this one has 2 solutions. Normally, if we're just graphing 2 lines, you'll just have 1 or none, as you know, or infinite. But this is different, so it's going to have 2. So solving a system by substitution. First thing that you should do is make sure, check to make sure, oh, sorry, not writing very well. Make sure one of the equations is x equals or y equals. Anyways, so you make sure one of the equations is x equals or y equals, and then you do what Drew said. You replace one equation into the other. Because that's what substitution is. So make sure you write it down so you have notes for later. Or maybe even today. You replace one equation into the other with what it's equal to. And then, what do we do after that? Solve the equation. Because at that point, you'll have a variable, one variable, and be able to solve. You'll either be solving for x or for y. It just depends. After you solve for one variable, you have to go back and plug back in to get the other variable, because there's 2, x and y. Plug back in to get the other variable. Lastly, this wasn't enough steps, write your answer as a point. Which is x, y. Do you have at least one equation that is x equals or y equals?
You have 2 of them.
You have 2, so you are more than okay to go ahead and get started. So they're both y equals, we're set. So now we replace one equation into the other. This is where it might get confusing, but stick with me.
Yeah, that makes no sense.
If you look at this bottom equation, it says y equals 5x minus 1. So 5x minus 1. 5x minus 1 is equal to y. So if I want to put that into the other equation, where should I put it?
Before the equal sign?
How come I should put it before the equal sign?
Because that's what y is.
Because it's y. Yes. So it's going to go into this spot because it's equal to y. What you're doing is replacing it with what it's equal to. Putting that into the other equation. Another way to think about it is since both of these equations are equal to y, they are equal to each other. So now, on to the fun part. Now we just have to write one equation. Instead of y, you put 5x minus 1. Hold on. And that's equal to negative 10x plus 29. So all I did was switch out y for 5x minus 1. Okay, this is an equation. You know how to solve equations. First thing you check for is distribution. Do you have it? No, there's no distribution. Do you have like terms? No. Kind of no, because they're on different sides, right? So we can't just combine them. You have to move them to the other side. So next thing is moving your variables to one side. I want to move 10x over there. So Evan, how would I move negative 10x to the other side?
Add.
Yeah.
The 5x.
Yeah, add 10x. If you do that, these cancel out. And you're left with, now it's 15x minus 1 equals 29. Jaden, what next?
You add 1 to the 1 to the 29.
Yep. Because it's being subtracted, do the opposite. And Eli, how do I get rid of the 15? Yes, because this is multiplication, and so you're going to divide to get rid of it. X is, oh, I'm not going to box it, actually. 2. So we get x equals 2, and now there's 2 variables, though, right? You have x. What else we need to get? Y. So now you're going to go back, take 2, and plug it back in. It does not matter which equation you choose to use. I usually just choose whichever one seems easier and is therefore less atrocious. So I like the bottom one, y equals 5x minus 1. What should I put in, no, where should I put the 2? Yeah, it goes, 2 goes where x is because it's equal to 2. So now I put y equals 5 times 2 minus 1. That would be 10 minus 1. So what is y equal to? 9. So x is 2, you plug back in, you get y is 9, and then you write it as a point, 2, 9. Huzzah! That's a system. You get both variables. You're just solving an equation. So where can I put the 3x plus 2?
After 2.
Yeah, what spot am I putting it in then? Yeah, put it in the y spot. Here, because it's equal to y. Okay. So you're going to get one equation. You're going to rewrite this bottom equation. X plus 2, but not y. What do I put instead? 3x plus 2 equals 11. And you're just solving an equation, which we've done a lot. Can I distribute? You betcha, and you need to. Remember, when we distribute, that means to multiply. Some of us have a tendency to add. That is wrong. Multiply. So x plus 2 times 3 is 6x, and 2 times 2 will get you 4. Can I combine like terms? Yes. Okay, remember this is a 1x. So when I combine like terms, what do I get? 7x. Undo the 4 by subtracting. This is just a 2-step equation. It's being added, so I subtract. And get rid of the 7 by doing what? Drew, what should I do? So x is equal to 1. Are we done? No, you have to take the 1 and plug it back in to get y. So let's think about this critically. Looking at your two options, you have y equals 3x plus 2 or x plus 2y equals 11. Which one seems easier to get the y value? Yeah, the first one is a heck of a lot easier. Both of them will work, but I always go for my easiest option. So plug in 1 where x is. 3 times 1 is 3. So what is y equal to? 5. Okay, write your final answer as a point if you want full credit. It's the answer 1, 5. Ooh, I don't want black. There we go, 1, 5. You can always check your work for these by taking that point and plugging into both equations to make sure it works out for both.